Hello everyone, my name is Mama Akil Aziz bin Azhar and my matrix number is E25P3635, and today I would like to talk about geochemical process in rock, water and soil. Geochemical processes are a natural chemical reaction that occur within the earth material, such as rock, soil and water. These processes control how elements and minerals are formed, transformed, transported and stored in the environment. They involve interaction between the Earth's atmosphere, hydrosphere, and lithosphere. In simple terms, geochemical processes explain how important elements like carbon, oxygen, iron, and other substances move and react within the Earth system. These processes are very important because they influence the Earth's structure, the formation of natural resources, and environmental conditions such as climate and soil quality. In rocks, geochemical processes mainly involve the formation and transformation of minerals due to heat, pressure, and chemical reaction. For example, rock can undergo weathering when exposed to air and water, causing them to break down into smaller particles. They can also melt under high temperatures and later cool to form new rocks through crystallization. Additionally, chemical reaction between minerals and fluids can change the composition of rock over time. These processes are important in the rock cycle and help create different types of rock, such as igneous, sedimentary, and metamorphic rocks. In soil, geochemical processes occur when rock breaks down into smaller particles and mix with organic matter, such as decomposed plants and animals. This leads to formation of soil and the development of nutrients that are essential for plant growth. Chemical reaction in soil, such as the exchange of ion and decomposition, help determine soil fertility and structure. Factors like pH level, moisture, and temperature also influence these processes. As a result, geochemical processes in soil play a key role in agriculture, ecosystem, and food production. In water, geochemical processes take place when mineral and gas dissolve, react and move through different water bodies, such as river lakes, oceans, and groundwater. Water acts as a medium that transports chemical elements from one place to another through processes like erosion and deposition. This reaction can affect water quality, including its acidity, mineral content, and suitability for living organisms. Over time, dissolved mineral can also settle and form sedimentary rocks. Therefore, geochemical processes in water are important for maintaining ecosystem and supporting aquatic life. Overall, geochemical processes in rock, soil, and water are, are closely interconnected. Change in one part of the system can affect the others. Together, these processes play a crucial role in shaping the Earth's surface, cycling, nutrients, and supporting life on Earth.
Hi everyone, my name is Muhammad Luman Hakim bin Karul Azhar. You can call me Luqman. My metric number is E25A3562. Today, I'm going to talk about geochemical process in soil. There's a quite few types of, there's quite many of geochemical process in soil. Today, I'm going to present to you about five first geochemical process in soil. Okay, for the first one is withering. Withering. Okay, what is withering? Withering, also known as a process that creates soils from rock and keep changing over time. It's normally happen in soil and sometimes rock. This mainly happen due to bedrock horizon breaks down to smaller particles like sand, clay, and also silt. The minerals mostly chemically change and releasing nutrients at the same time. Fun fact, there's three types of withering. The first one, we call it physical withering, or also known as mechanical withering. There's a chemical withering and also biological withering. But I'm going to talk about withering soil. As you can see from the slide behind me, there's a picture, right? picture behind me is also known as a land horizon. There's quite a few of horizon land, about 5 I think. O, A, E, B, C I think. We got organic layer, topsoil, subsoil, bare material, and bedrock. The ones that are happening, the withering in soil is the bedrock. The bedrock breaks over time and it creates clay, sand, and silt. And most of the particle that breaks from the bedrock uh, going upwards towards the top layer. Okay. Okay. You already heard about the withering. Next one, I'm gonna talk about leaching. What is leaching? Leaching usually happens when water moves downwards and also carry dissolved nutrient away from the topsoil. This is a geochemical process in soil. Listen, leaching also happens in soil. It usually happens when it's raining, since the water enter the soil and somewhat dissolve the nutrient at the same time. Water wash the nutrient at the same time, deeper in the soil. Yes, take a look. I put a picture in my slide of presentation. You can see there's a rainwater coming down, okay, from the slide, and the rainwater carries the nutrient from the topsoil or organic layer, right? Because we put a lot of we put baja on land, so the water dissolve it, and it coming deeper towards the soil. That's for leaching. Okay, the third one, I should call it dissolution and precipitation. Dissolution is a process when nutrients dissolve in water. Meanwhile, the precipitation is a process where the nutrients become solid back again. It normally happens when plants take nutrients for the soil water during the rainy season. It also may happen when the nutrients react with acid or alkaline in soils and then become solid. Okay. For the dissolution, it has a connection with the leaching. Because what? Both of them connected with rainwater. Leaching, rain, it came down and then been dissolute by the root of the tree. Leaching is for the land. Dissolution is for the roots of the tree. There is like a dissolution spread like that. And meanwhile, the precipitation is connected for our fourth point. I'm going to explain to you later. It's just when a nutrient react with acid or alkaline and then it became solid material like that. Okay? Okay. We already reached our fourth point. As I can say before, fourth and third point is connected. Because what? The fourth point, the precipitation, is connected to acid and alkaline. Meanwhile, the fourth point is a soil pH property. What is it? To explain it in simpler terms, soil tries to resist sudden pH changes. It uses clay and organic matter to stabilize the pH to keep it natural. pH affects the nutrient availability. Low pH may result in toxic material, meanwhile the pH may result in nutrient deficiency. Okay, meanwhile, you can see like when there's the land need to keep it natural to be healthy. So when there's a pH changing, either acid or alkaline, the soil tries to change and thus it became solid, so that it cannot be dissolute by the plants. Get it? Like that. Just like that. Okay. Okay, to our last point for geochemical process, which is absorption and desorption. Nutrient normally sticks to soil particles. It's called absorption. For the desorption, the nutrient released to the soil. I give you an example. In soil, what kind of particles that's been called absorption? One is clay. For the desorption is sand. Because what? Have you ever seen water stuck in the sand in the beach? Mostly the water just go through the sand. So that's what we call disruption. If you can see, the definition of disruption is nutrient released through the soil is like it move
Next,
through
I
like that.
want to talk about
Okay,
geochemical process
that's all
in
for me.
rocks.
I'm going
Before
to pass
that, I
this
want to introduce
to my
myself.
next.
I am Nafatiha binti Muhammad Isa. You can call me Tea. So, my first point is weathering. Weathering is a geochemical process that involves the breakdown and alteration of rock at or near the Earth's surface through interaction with environmental factors such as water, oxygen, carbon dioxide, and organic acid. This process does not involve movement of material but occur, meaning the rock is decomposed where it originally exists. Weathering can be broadly divided into physical and chemical type, but in geochemistry, the focus is mainly on chemical weathering. Chemical weathering occurs when minerals in rock become unstable under surface conditions and undergo chemical reaction to form new, more stable minerals. These reactions include hydrolysis, oxidation, and carbonation. For instance, Velspar, a common mineral in granite, react with water and hydrogen ion to form clay minerals such as kaolinite. This transformation weakens the structure of the rocks and changes its composition. Another important aspect weathering is the release of dissolved iron into the environment. Elements such as Elements such as calcium, sodium, potassium, and magnesium are released into water system and transported through river into ocean. This process plays a crucial role in regulating the Earth's geochemical cycle, including the carbon cycle, as weathering can remove carbon dioxide from the atmosphere through carbonate formation. Overall, weathering is essential in shaping the Earth's surface and forming soil which is support plant life and ecosystem. It also provides sediment that later becomes sedimentary rock. Without weathering, the recycling of material in the Earth system will be significantly reduced, affecting both geological and biological process. Secondly, metamorphism. Metamorphism is a geochemical process in which existing rocks are transformed under conditions of high temperature, pressure, and the presence of chemically active fluid within the earth crust. Unlike melting, metamorphism occurs in the solid state, meaning the rock melting is solid from while undergoing mineralogical and structural change. This process usually takes place deep beneath the Earth's surface. During metamorphism, the mineral within a rock may recrystallize, grow large, or change into entirely new mineral that are stable under the new condition. These changes are driven by variation in temperature and pressure, as well as the introduction of fluid that can enhance chemical reaction. For example, limestone is recrystallized into marble, while shale can transform into slate or schist. Metamorphism can be classified into different types depending on the environment in which it occurs. Contact metamorphism happens when rocks are hit by nearby magma, resulting in localized change. Regional metamorphism, on the other hand, occur over large areas due to tectonic force, such as during mountain building events where both high pressure and temperature are involved. This process is very important because it produces metamorphic rock with distinct texture and mineral composition, which can provide valuable information about the geological history of region. By studying metamorphic rock, geologists can determine the pressure, temperature, condition, and tectonic events that have effect an area over time.
My name is Sadira binti Sulaiman. My number matric is E25A3682. Today, I will present about the geochemical process in rock focused on the sedimentation, melting and crystallization. First of all, sedimentation is the process where the sediment like sand, mud and small rocks fragments settles and accumulate in places such like river, lakes and ocean. This process consists of the three main stages. First is the deposition, where the sediment settle when the energy of the water and wind decrease. Heavy particles settle first, followed by the finer particles. Second is the compaction. As small sediment accumulate, pressure increase and water is squeezed out, making the sediment more compact. Lastly, cementation, where the minerals such like silica or calcite act like glue to bind the sediment together into the solid rocks. These three processes together are called lithification. Sediment is important because it forms sedimentary rocks and store elements like carbon and calcium. It also plays a role in the formation of fossil fuels such as like petroleum and natural gas. In short, sedimentation transforms loose sediment into the solid rock through the deposition, compaction, and cementation. Okay, the next is melting and crystallization. Melting occurs deep inside the earth when the rocks are exposed to high temperature, reduced pressure or presence of the water. This causes rock to melt and form magma. This is usually particle melting, meaning not all the minerals melt at the same time. After that, crystallization occurs when magma cools and mineral beings to form the crystal. Different minerals crystallization at different temperature following the Bowen's reaction series. The cooling rates play an important role. Slow cooling produces large crystal, just as in the granite, where the fast cooling produces small crystal, such as in the basalt. This process is important because it forms igneous rock and controls the mineral composite of rock. It also contributes to the formation of valuable resources like gold and copper. In summary, melting and crystallization are the key processes that form igneous rock and influence Earth's geochemical system.
Hello, my name is Arwin McLean and my metric number is E25A3588. Right now, I would like to explain about geochemical process in water. First process is dissolution process. During this process, solid rock minerals dissociate and their ionic compound are dispersed into liquid solvent, which is water, and breaking down rock structure. It's also breaking apart solid crystal via hydration, where water molecules surround and detach ion, as seen in salt dissolution. There are two types of dissolution, known as mineral dissolution and physical or chemical change. Mineral dissolution, driven by acidic water, breaking down rock like limestone or feldspar. Physical or chemical change mean acidic water break down ionic compound. There are also factors for affecting dissolution, known as temperature, fluid chemistry, agitation, and surface area. Next process is hydrolysis. This process means water react with mineral to form new compound like clay mineral, at the same time weakening the rock structure. One of the rock is known as granite. Mechanism of hydrolysis is water molecule, often with hydrogen ion, chemically react with mineral, breaking their bond. This process also soften the rock and release dissolved ion. Third process is oxidation. Oxygen react with mineral that contain iron to form oxide or hydroxide, altering the rock structure and often imparting reddish hue. For example, rock like basalt and sandstone. In the presence of water and oxygen, iron to ion in mineral, converting it to iron 3 ion and form compound like hematite. And the last process of geochemical process in water is hydration. Mineral absorb water molecule into their crystal structure, causing expansion and weakening the rock. For example, clay-rich rock. Mechanism of hydration occur when water molecule bond with mineral structure, consequently increasing their volume. This expansion exert pressure within the rock, leading to fracturing and disintegration. Next, there also effect on geochemical process in water. First is mineral weathering. Rainwater react with rock weathering mineral and releasing ion into groundwater, elevating total dissolved solid. For example, ion like magnesium. Next, ion exchange. Clay mineral and sediment are exchanged ion with water, commonly substitute sodium or magnesium in shallow groundwater, altering water hardness and sodium absorption. Third is redox reaction. Microbial activities induce redox reaction, which is oxidation and reduction, controlling the mobility of nutrient and metal. For example, ion reduction in aquifer, which can affect water potability. Last one is evaporation and salinization. In arid area, high evaporation rate concentrate solute in shallow water, leading to increased alkalinity and salinity.
Hello, my name is Mr. Buyong Arasap. Today I will be presenting our conclusion. First is soil. In soil, weathering releases nutrients, leaching redistribute them. Dissolutions and precipitation circle them between solid and liquid stage. Buffering stabilize pH and desorption regulate nutrient retention. In conclusion, geochemical processes in soil are essential for maintaining soil fertility and supporting plant growth. Processes such as weathering break down rock into smaller particles and release important nutrients, while leaching redistribute these nutrients within soil layer. Dissolutions and precipitation control the availability of mineral in soil water, and pH buffering help stabilize soil conditions to prevent extreme acidity and alkalinity. Additional absorption and desorption regulate how nutrients are stored and released by soil particles. Together, this process ensures a balanced nutrient cycle, making soil a dynamic and life-supporting system. Second is rock. In rock, weathering breaks them down, metamorph, transform them under heat and pressure. Sedimentations store elements and forms sedimentary rocks, while melting and crystallizations generate igneous rock and mineral resource. In conclusion, geochemical processes in rock play a crucial role in transforming earth material over time. Weathering breaks down rock at the surface, deep within the earth. Sedimentations lead to the formation of sedimentary rock through depositions, compaction, and cementation. Furthermore, melting and crystallizations contribute to the formation of igneous rock and control mineral compositions. This process continuously recycles earth material, forming new rocks and strong, important elements and natural resources. The last one is water. In water, this solution disperses mineral, hydrolysis form new compounds, oxidation alter iron-rich mineral, and hydrations expand and weakens rocks. In conclusion, geochemical processes in water are vital for the movements and transformations of mineral and elements in the environment. The solutions allow minerals to break down and mix with water, while hydrolysis chemically alter mineral into new compounds. Oxidation changes the chemical state of elements, especially metal like iron, and hydrations weaken mineral structure by absorbs the water. These processes influence water quality, mineral transport, and chemical interactions, making water a key medium in chemical cycle. Together, these processes continuously recycle and transform earth materials, regulating nutrient availability, soil fertility, rock formations, and water quality. They interconnect to sustain ecosystem, shape landscape, and provide essential resources for life human use. That's all from us. Thank you.